Welcome back to solving radical equations, but this is now part 2, which means that we're going to get into some more complicated problems. Just so that we can kind of sort out the weird things that are going to happen, I thought it would be a good idea if we started with some graphs. So when we're solving radical equations, we're really finding when a line, whether like a diagonal line like this with a positive slope or perhaps with a negative slope, or even just a horizontal line, right, with a zero slope, how many times that line intersects a radical function graph like this. So let's think about how many intersections we could possibly have with these two things. So pause the video and really think about that. If you had to draw these two shapes like overlapping, how many intersections could you get from them? What's the least amount? What's the greatest amount? Okay, so now that you've had a chance to think about that, you may have forgotten one of the ways that these could intersect, and that's not at all, right? Don't forget that this end right here is an endpoint, it's not an arrow. So we could have a situation where this graph is completely above this line, right? And they don't intersect at all. So we could have 0 intersections. There is a way of having one intersection, right? If we had a radical graph and the line goes through it just one time like this. But is it possible to get more than that? And it actually is. If I just moved this line right on top of this graph right here, try to do my best to recapture that, right? Something like this, we could get 2 intersections out of it. But we're not going to get any more, right? There's no way that we're going to get a 3rd intersection out of that. So we have 3 situations. And look at that, coincidentally, I have 3 equations that I want us to solve. So each of these equations is going to be a different one of these situations here. All right, so let's jump into things. Let's do some solving. And remember, what that means is that now these equations either have 0 solutions, 1 solution, or 2 solutions. One of those 3 things is going to happen. Okay, so why is this harder than last time? We are still going to isolate the radical before we square, okay? Before squaring both sides. Oops. All right, so why is this going to be more difficult? Well, when we do our squaring here, we actually might wind up with a quadratic. So let's see what happens when I square this. Our radical right here has been isolated. Isolated means there's nothing in front of it, there's nothing in back of it, it's ready to get squared. That means we're also going to have to square the entire right side. So on the left, we're squaring it to cancel out the square root, right? So we just have that x minus 2. But over here, we actually have to do some work. Let me jot down that work right here. In a little box, I'm going to multiply x minus 4 times x minus 4. We get x squared minus 4x minus 4x plus 16. Okay, so now we're going to combine our like terms in there. You know what, let me just move this over so I have some room. Okay, so we had x minus 2 on the left, and over here on the right, we get x squared minus 8x, because these can go together, plus 16. And this is why it's a more difficult problem, because now we have an x squared in our equation here, which means we have a quadratic that we need to solve. And to do that, we want to set it equal to 0. So I'm going to move this x over by subtracting x on both sides, and I'm also going to add 2 to both sides to get rid of this 2. So now we have a 0 equals x squared minus 9x plus 18. Think about the best way of solving this. We always like to factor if it's possible. I believe that we can factor this one. Let's give this a try. Numbers that multiply to 18, 6 and 3 work, and we want them to add up to -9, so I'm going to go with negative, so -6 and -3. And now if I set each factor equal to 0 and solve for x, I get x equals 6, and over here I get x equals 3. Do not just circle those right away though, because here is where the real work starts to happen. I know that either none of these answers are going to actually be answers, one of these answers might be an answer, one of them might not be, or both of them will be answers. I now have to figure out which situation it is. That means it's time to check. I now have to check each of these answers, and when I do a check, I have to plug in to the original. So here we go. I'm going to plug 6 in for the x. You are not solving this. You are not going to be squaring both sides of this. There is no variable left over. All you have to do is simplify. So we're going to do the 6 minus 2 inside of the square root. We get to 4, and then we're going to take the square root to get to 2. You don't change any of these symbols, and you don't move things from left to right. There's like a brick wall here. You just simplify what you get on the left, and you simplify what you get on the right. So let's see, on the right we get 2. If these two numbers match, you have an answer. So 6 is a good answer. Now we're going to check 3. So we're going to do the same process as again. I'm going to go back to the original. I'm going to plug in 3 wherever I see x. Now, again, brick wall here. Just simplify the left and see what you get. So inside there, we're going to get a 1, and then the square root of 1 is 1. Over here on the right, 3 minus 4, I get -1. And there we go. We have something that's not true. Right? That is not going to work. We're going to cross out that x equals 3, and we're going to use a new word right now. That is called an extraneous solution. It's an extra wrong solution. We got to it. We didn't make any mistakes to get there, but our algebra led us to this answer because we were solving a quadratic. We switched from this radical to a quadratic, and weird things happened. So it's our job to make sure that our answers are actually answers. So here, we only had one solution. Okay, so let's see what else we can make happen here. All right, so remember, we're gonna isolate the radical before we square both sides. So on this problem, here's our radical. It's not isolated though. We have an x plus that radical. This x plus needs to get moved to the other side. So I'm going to subtract x from both sides. Now I have a 1 minus x equals the square root of 2x minus 3. Now it's isolated, and now it's ready for squaring. Okay. And I'm going to do my work over here to square. So I have to do 1 minus x times 1 minus x. And let's see what we get. 1 minus 1x minus 1x. And here we get plus x squared. Okay. Let's combine our like terms, right? These negative 1x is going to get together, but we have, let's write this in standard form as well. So we'll do x squared first, minus 2x plus 1. So this was my work to square the left side. The radical side's easy. We just cancel out the square and the square root. They undo each other, and we get that 2x minus 3. we just went from having a radical to having a quadratic. Now we have to solve this quadratic equation. So we want to set that equal to 0. We have minus 2x on both sides. And these don't cancel, right? They're both negative. Plus 3 to both sides. And now we get x squared minus 4x plus 4 equals 0. Let's see if we can factor that one. What multiplies to 4? 2 and 2. But we want them to add up to negative 4, so let's go with negatives. That works because then they still multiply to a positive 4. And we get x equals 2 and x equals 2. Okay, so we get the same answer here. So really we only have to do one check. So either we're going to have 2 as an answer or we're not going to have anything as an answer. So let's plug 2 back into the original. And remember, you're not allowed to move anything or square anything to cancel anything out. You're going to leave everything as it is and just use it to simplify. So the left side's done. We have a 1. So we really just have to do work on the right side here. So let's see, we still have our 2 plus the square root. Inside of here, 2 times 2 is 4, minus 3 is 1. And now let's take the square root of 1 to get 1. 2 plus 1 is 3. That does not work, does it? This is an extraneous solution. And they match, right? These are both the same extraneous solution. So let's see, there's nothing to box here. So if there is no answer, what do we say? That's when we say no solution. Even though we got to these x equal 2's, they are not answers, they're extraneous, and we don't have a solution. Okay, so we've had our one intersection example, our no intersection example. What are we missing? We're thinking that this one's going to be 2, so let's check it out. Okay, we need to isolate our radical. That means this minus 3 has got to go. Let's switch over to blue here. Minus 3, goodbye. And now I have, move it over here, the square root of 3, x minus 9 on the left, and on the right we have x minus 3. It's now time to square both sides because the radical's all by itself. So we have to go to work squaring x minus 3. So x minus 3 times x minus 3. We get x squared minus 3x minus 3x plus 9. And we're going to combine our like terms there. We get x squared minus 6x plus 9. And on the left side, we're going to cancel out the square and the square root, and we get 3x minus 9. All right, another quadratic. We need to set it equal to 0, minus 3x on both sides, plus 9 on both sides. We now have a 0 on the left, and we have x squared minus 9x plus 18x on this side. Well, that's interesting. We had that one over here. I'm going to skip down to our factors and our answers that we got here because we've already done this work, right? We know that we get x equals 6 and x equals 3. It's a different equation though, which means that we still have to check in the original equation. Remember, we're checking up here. So I'm going to plug 6 in for x. Oops. There's our left side, there's our right side. Our right side's already simplified. So here we go. Inside we get 18 minus 9. 18 minus 9 is 9. And the square root of 9 is 3. That combines with the 3 to get 6. This time the 6 worked. Now we're going to check the 3. Plugging 3 in for x. Keep drawing that too long. And we're going to check this one out. All right, so inside of here we get 9 minus 9. 9 minus 9 is 0. And the square root of 0 is 0, which means we get a match again, right? We get 3 and 3. And there's our 2 solutions, right? So we've seen all 3 things that could possibly happen. Either none of them work, one of the 2 work, or both of them work. So that's what's going to happen when you're doing your practice. Good luck with that.